Hello everyone, InfoSec Pandey here, and welcome back, Analyst in Training. And we are getting deep into the juicy part of blue teaming now, use case that actually get people's attention in a SOC. So today we are digging into data exfiltration and lateral movement, two of the biggest red flag in cybersecurity monitoring. And no, these are not theoretical fluff. These are real world resume worthy skills. So master these and you will start seeing how attackers really move inside a network, and more importantly, how to detect them before things hit the fan. So let's dive in. What is a use case in SOC again? So use case in SOC context is basically a specific detection scenario that answers this question. So the question is, what suspicious or malicious behavior are we trying to detect and how? So so basically we are getting what and how. So basically we are finding what and how in a use case. So use case is not just about writing query. So use case is not equal to writing query. So most people think use case means writing custom query or correlation query in SIEM, but it is about understanding the attacker's goal, mapping it to their behavior, and building detections that light up when those behaviors occur. So use case is not equal to writing query. Use case equal to understanding attacker's goal, mapping to behavior, and building detection rule. All right, so let's start with the first offender, data exfiltration. So data exfiltration. And what is data exfiltration? So basically, data exfiltration is when an attacker or even a malicious insider transfers sensitive data out of your network. So you can see here is a attacker who is trying to send data over the wire to a third party network. So think of it like the grand finale of an attack. So this is a grand finale because attacker already got access to your network and he's solving his purpose now. So it's a grand finale, I would say. So they have done the recon, they have already done the recon and poked around, and now they are stealing. So that's why it is a grand finale. So this could be an intellectual property, customer data, credentials, anything that they can profit from or weaponize. So data like sensitive data, customer data, credentials, anything else. And why it is matter? So you could have the best firewalls, the most tuned SIEM, and 2FA everywhere. But if you don't catch someone leaving with the crown jewels, what was it all for? Worse data exfiltration is often subtle, and attacker might use some legitimate tool like curl command or SCP or even emails. Okay, encrypt the data to hide it. So they encrypt the data so they encrypt the data so you cannot read it. or you cannot detect it in cloud. Also, break it into small chunks and send it over time. So in this scenario, attackers send small data over the time. So suppose they sending it hourly or weekly or daily. So that's called the weakening. And they also use some well-known cloud storage like Dropbox, Dropbox, Google Drive, OneDrive, etc. All right, and what is the common indicator of data exfiltration? So let's look at what you should be watching for. So number one, unusual data transfer volume. So check for the volume, and suppose a user or system suddenly uploading gigabytes to a third party cloud, so that's a red flag. So there is a user who started uploading data, suppose 10 GB to a third party cloud like Dropbox, so it's a red flag. So what you can do in this case, so you can compare the uses to a user's normal behavior. So you can check the baseline, check the user's baseline. All right, so number two, we have the second indicator is unusual protocol or destination. So check for the protocols and destinations. So internal systems talking to external FTP. So suppose there is a system or server which is talking to an external host using FTP, or it is talking to a cloud, third party cloud storage, or any personal email domain like infosecpande.com. So this is an indication of data exfiltration. So check for the uploads via non-standard port or out of band channels in this case. So you can check the non-standard. All right. So the third we have, so the third we have is like after our transfer, after hours monitoring. Okay. So suppose a large upload at 3 a.m. from HR's laptop. Yeah, that's suspicious. And then number fourth, we have uses of compression and encryption tools. So check for the large file compressions or encryption activities. So you can check the 7-zip and WinRAR or OpenSSL or any common or custom encryption script right before the transfer. So this is also a indication of data exfiltration. All right. So what custom detection rule or query you can create? So here is a KQL query example we can write. So we can check for the device network events, and then where action type equal to connection success. And also we can include the remote URL. So remote URL is your destination. Remote URL contains dropbox.com, or remote URL contains drive.google.com. You can add more, but I'm not adding it right now. And also you can summarize it. Summarize total byte equal to sum and sent byte by device name, account, remote URL, and then also we can put the bin. So bin is like time generated and 1 hour bin. And also another filter we can put to reduce the noise, where total bytes greater than, which is 50 MB. So this is in KB. Okay. All right. So this is a KQL query that I created. So this is checking the connection success and then remote URL Dropbox or drive.google.com, and then summarize the fields and also bin, and then total byte is more than 50 MB. Okay, similarly, we can create the SPL query. So SPL query, we can start with the index equal to network traffic, and then we can put a source type here. Source type equal to pan traffic, or source type equal to gscalar log, and then pipe. So search for destination domain, in dropbox.com or drive.google.com, etc. And then states count. So instead of a state count, we can use the states sum byte out as exfil byte by source IP, user, and destination domain. And then a filter that reduce noise. So where exfiltration byte greater than 50 MB. Okay. So tune your threshold based on historical norms. So what is unusual for marketing might be business as usual for engineering. So that's the pro tip. Lateral movement. So lateral movement is how attackers expand their control within your network after the initial breach. So they are not in it just for one system. They want to domain controller, the file server, the backup server, and the crown jewels. And they might dump the credential using tool like Mimikatz, or they can use the legitimate tools like window legit tools like PsExec or WMIC or the RDP. And access share across the network. So access share and move slowly to avoid detection. So they go on one system, then second, then third, then many computers. All right, so why it matters? So once an attacker start moving laterally, they are looking for privilege escalations and persistence. So suppose attacker move laterally, then they look for the privilege escalations or persistence. Okay, so the longer they move around undetected, the more dangerous the breach will be. So that's why stopping them or detecting them early can stop a bigger attack in the environment. So early detection for lateral movement can stop attacker before they get into the critical systems. All right, so what are the common indicator of lateral movement? So number one, remote logins between workstation. So remote login. So lateral movement often involve horizontal access. So suppose a marketing machine RDPing into another marketing machine. So that's unusual. So there is a marketing machine, there is another marketing machine, and it is doing the RDP access. So that's suspicious because they are into the same environment, but why they are doing the RDPing? So that's unusual. And the second indicator we have use of admin tools. So admin tools like PsExcs or WMIC or remote desktop tool or the power cell remoting. So these are the tools which are commonly used by admins. So we should monitor these tools for unusual behavior. And then the third indicator we have account anomalies or behavior anomalies. So suppose a low privilege user suddenly accessing multiple endpoints. So suppose we have a help desk user, and he started accessing the domain controller. Okay, and also I spike in Kerberos ticket. So Kerberos ticket spike into Kerberos ticket request like golden ticket or pass the hash, So these are the unusual behaviors. All right, next indication we have is like the new service creation. So attacker often creates service to execute command remotely. So we should monitor the new service creation or any scheduled task creation to detect the lateral movement. So here we have some sample query. So we have KQL query that we can write to detect the PsExec like behavior. So PsExec like behavior. And we can start with the device process. So device process events, and then we can apply a filter where file name in PsExec.exe or PsExecSPC.exe. So these two filter we can apply, and then we can apply another filter for summarizing the data. So summarize count by device name, account name, file name, and then we can use the bin here. So bin is like timestamp and 1 hour. Okay, so this query we can use in Sentinel or Defender to detect the PowerShell exe like behavior. And also we can write a SPL query. So similarly, we can write SPL. So SPL query for detecting RDP lateral movement. So we can start with the index equal to Windows, event log, and the event code we can use 4624, which is normally used for successful login. But there is a logon type that we can use for interactive remote login. So logon type equal to 10, which is for remote access. And then we can just do the states, count by user and source IP and destination host, and also the time. And we can apply a filter to reduce the false positive. So where count is more than or greater than 5, so this will reduce the false positive and provide the real events. So this is how we can write the queries to detect these kind of attack or lateral movement attack. And then we have real world examples here. So some real world. So let's say here is an attacker who is doing the phishing in a finance account or finance user system, and they got the foothold and ran the command from the system. So they ran the who am I, and also netview, and also net use. So they ran 3 commands to do some reconnaissance, and they have found that there are some HR systems uh, they can access. So they have got the HR system here. This is the HR system, and they tried access to it using brute force, and they got the access. And then access is using RDP, using some stolen credential or brute force attack. Then they dumped all the credentials, and uh, then they dumped all the credentials from HR system. Then they hop over to the IT system. This is IT system. They logged in as IT, and they got the root privilege. And from there, they started accessing the many systems until they got the access to the domain controller. And once they get the domain controller access, then game over. So that's the lateral movement, and it can happen in hours. So that's the life cycle of the lateral movement. How to investigate these use cases? So investigation part. So the first we have is data exfiltration. So how to investigate data exfiltration? So let's create a small checklist here. So when you see the data exfiltration alert, you can start the investigation with these points. So confirm the destination. So the destination if it is an external or internal, so external IP or internal IP, and also domain. Then also we can look for the data sent, which is normal for the user or it's a suspicious. So data sent and then user baseline, so that we can get using UEBA, and look for the file type being transferred. So file type, whether it's a resume or salary slip or any credentials or sensitive information from the organization, and was the encryption or compression used. So encryption and compression, encryption, compression, and also we can check user activity before and after the transfer. So user anomaly, and also we can check was it a one-time spike or consistent over time. So one time or beacon. All right, so this is how we can investigate the data exfiltration. And the next we have lateral movement. So when you see an alert for lateral movement, what you can check? So we can check the login timestamp and system accessed. So login time and how many systems, and also we can see the event IDs, the event ID 4624, which is for login, 4688 for process creation, and also we have 7045. So these are the Windows event ID that we can monitor, and these are the sign of lateral movement, and map the user's usual login behavior. So check for the user's login behavior. So that's called baseline. Then also investigate the tool used. So tool used like PowerShell, PsExec, and also these are the common admin tool. And also check for the was there any privilege escalation. So check for the privilege escalations and look at the next step. Was a new account created? So see if a new account created in the same timeline. So this is how you can investigate the lateral movement, and then how to build detections. So understanding the TTPs while creating the detections are very important. So TTP is like technique, tactic, and procedure. So these are very important part, and you can use the MITRE attack to guide what to detect. For example, for the data exfiltration, what you can detect. So data exfiltration, you can see the technique ID 1041 and 1567. So these two technique ID will tell you about the data exfiltration and the lateral movement. So for the lateral movement, T1021 and T1086. All right, so what logs we can use? So we can build a detection logic based on logs. So the important logs are like EDR, and firewall logs, and also authentication logs are very important logs that we can use to create the detection rule. And then how to test it? So for the testing, we can use some tool called atomic red teaming and Caldera, and there are some other tools available that we can use to create simulation. So we can attack, we can simulate the attack in lab using these tools. and then tune it. So for the tuning, uh, we can apply some filters and also the exclusions and some whitelisting. So tuning will reduce the false positive, and you don't want your alert drawing in noise, right? And then also we can, then after tuning we can do the documentation. So documentation, what documentation we can do? So we can do like use case, its description, and data source, and also the detection logic. And then also we can document the MITRE technique, tactic, and procedure, the TTPs, and severity and response plan. So this is what we can document, and that's it for today. So data exfiltration and lateral movement are not beginner concept. So they are not the beginner concepts. They are not beginner concepts, okay? And they are the stuff of real world mature SOC operations. But here is a good news: you can learn to detect them if you approach it methodically. So it is not about memorizing 1,000 alerts. It's about understanding how attackers think. So once you do, everything else clicks. So keep practicing these queries and these detection scenarios, and keep asking questions, and keep building your detection muscle. So that's huge for today. You have already learned more than most people dipping their toe into blue teaming ever will. And if you like the video, just hit the like button and subscribe.